This video was made for Unit 9 review. We are to find the domain and range of exponential functions. It says, what is the domain and range of the following problems? Alright, so the first thing we need to kind of remember is that when we talked about, we said the a, the b, and the x for the exponential function. The a is my initial value. It's what we start with. Also, if a is positive, alright, then my range will be y is greater than 0. If my a is negative, then my y will be y is less than 0. All right. Remember, the domain is always all real numbers because we have arrows on the end of each of these, and they kind of go on forever. I mean, this is not going straight down; it's going at an angle, and so as time goes, we will. I mean, no matter what, this is going on forever. All right, so when you're doing this, you need to make sure you note that domain is really going to be all real numbers every time. So both these are going to be all real numbers. Even this one, the graph, is all real numbers. The range. All right, so look at where the a is. The a, this one is positive 10. So if it's positive, that means I'm going to say y is greater than 0. So now look at, if you graphed it on a calculator, you would actually see that the graph goes up similar to this right here. On number 2, if you look at a is negative 6. So if it's negative, that means it's going to be y is less than 0. Now remember, the number inside the parentheses, the b value, is my growth or decay. If that number is greater than 1, it's a growth. If it's a decimal or fraction, it'll be a decay. Alright, number 3, like we said, was all real numbers. Now, this one's a little different because we don't actually have the equation, but here is this right here is my asymptote. It's at y equals 0. And you can see that the graph is like basically below the y equals 0. So, of course, below means less than. So, y is less than 0. Alright, that's how you do those 3. Alright, so number 4. The function f of x, 1.5, is shown to the right. If the function is translated up 2 units. So, first, you want to find your y-intercept. The y-intercept is right here. This is my y-intercept. I'm going up 2, so if I go up 2, there's 1, there's 2. So this is up 2 right here. And I'll do this in a different color so you can see the difference. So this is up 2. All we're doing is just going up on the y-intercept. It wants to know what is the new y-intercept. Well, now this is my new y-intercept, so I just count. 1, 2, 3. So if it was at 1, now it's at 3. So my y-intercept is 0, 3. So where is my horizontal asymptote? Well, my horizontal asymptote, since the whole thing is shifted, so has my asymptote. And so I'm going to go back to blue. So my asymptote is at 0, all right? And I go up 2 more units. That means my new asymptote will be up 2, 1, 2. So it'll be right here. And that's when y is 0. I'm sorry, y is 2. So this one, I'm like blah blah blah. So this one is y equals 0, and then this one will be y equals 2 because it went up 2 units. So my new equation for the horizontal asymptote is y equals 2.